Good morning. Welcome to another edition of A for A Levels by my tutor. Today we're going to go through mechanics. March 2021, paper 42. Let's go. Two particles P and Q of masses 0.2 kilogram and 0.3 kilogram respectively are free to move in a horizontal straight line on a smooth horizontal plane. P is projected towards Q with speed 0.5 meters per second. At the same instant, Q is projected towards P with speed of 1 meters per second. Q comes to rest in the resulting collision. Find the speed of P after the collision. Like in all mechanics question, it is best to draw out your problem so it's easier to solve. 0.2, 0.3. This is Q. It's moving towards Q is moving towards P. P is moving towards Q at 0.5. This is 1. After the collision, Q is stationary. I will put P. This is the speed of P. Okay. So this is the law of conservation of momentum. So before the collision, the momentum is 0.2 times 5 plus 0.3 times 1 equal 0.2 times negative V. I put negative V because I'm taking to the right as a positive value. So here you have 0.2 times 5 is 1. 0.3 times 1. Oops. 0.2 times 0.5. So it's 0.1 plus 0.3 is 0.4. Oops, sorry. This is minus, because Q is in the opposite direction. 0.1 minus 0.3 is minus 0.2 equals to minus 0.2 V, and therefore V equals to 1. That is the solution. Let's go to the next question. Car of mass 1,400 kilograms is traveling at a constant speed up a straight hill inclined alpha to the horizontal where sine alpha equals to 0.1. There is a constant resistance force of magnitude 600 Newton. The power of the car's engine is 22,500 watts. Show that the speed of the car is 11.25 meters per second. So let's draw. Sine alpha equals 0.1. Car is moving up. This is my car. The weight is 1,000 or 14,000 meters. And there is a resistance of 600 Newton. 600. This is my force pulling the car. Okay. So the key words are constant speed. And the speed you have to find V. So power is FV. Okay, power is 22,500. Since it's traveling at a constant speed, the resultant force is 0. So the force going up and the force coming down would be equal. So F will be 600 plus 14,000 sine alpha times V. V equals 22500 over. This is 600 times 1,400 plus 1,400. So it's 2,000. So 225 over 20. So the answer is 11.25. That's it. Sure. Okay. The car moving with speed 11.25 comes to a section of hill which is inclined at 2 degrees to the horizontal. Given that the power and resistance force do not change, find the initial acceleration of the car up this section. So now the section now has an angle of 2 degrees. So you have the car still the same, 14,000 newtons. The force, this force is, just now we had it as 2,000 newtons. Resistance is 600. So what is the resultant force? The resultant force is your thrust, which is 2,000 minus 600 minus 14,000 sine 2 degrees. It is this weight down the plane. Okay, so the resultant force is MA. Always resultant force is MA. So this is 1,400 A equal 2,000 minus 600 minus 14,000 sine 2 degrees. 911.4. Six five one 0.651 meters per second. Okay, that's it. Question 3. A particle Q of mass 0.2 kilogram is held in equilibrium by two light external string, PQ and QR. P is fixed point on the vertical wall and R is a fixed point on the floor. The angle which strings PQ and QR make the horizontal are 60 degrees and 30 degrees respectively. So in this question, diagram is drawn for you. Okay, let's put the tension in QR as T1, tension in PQ is T2. Now always when you solve problems with forces, always identify all the forces. Okay, and the weight is 2 Newton. Okay, so this is in equilibrium. So you can you can always solve by resolution of forces or drawing a closed vector diagram. Since this vector diagram is not right angle triangle, I'm gonna solve via resolution of force. Resolving vertically, we have going downwards will be 2 plus T1 sine 30 degrees. This one resolve downwards sine 30 degrees will be equal to this one resolve upwards. Okay, equal T2 sine 60 degrees. Okay, sine 30 is half, sine 60 is 3 over 2. So you have T2 root 3 over 2 minus half T equals 2. Now resolving horizontally, this to the left and this to the right. So you have T1 cos 30 equals to T2 cos 60. T1 root 3 over 2 equals to half. T1 equals to T2 over root 3. Substituting into the first equation, oops, this is T1. Substituting in the first equation, you have root 3 over 2 T2 minus 1 over 2 root 3 T2 equals 2. 3 over 2 T2 minus root 3 over 3, root 3 over 2. 4, 2 root 3 over 3. Root 3 over 3 T2 equals 2. This is minus. So it's 3 root 3 minus 2 root 3 over 6. So root 3 over 3. 1 over 3, 3, 2 over 3. So T2 2 root 3 Newton. Therefore, T1 2 root 3 over 3 root 3 is 2 Newton. There, we have it. An elevator moves vertically supported by a cable. The diagram shows a velocity time graph which models the motion of the elevator. The graph consists of 7 straight line segments. The elevator accelerates upwards from rest to a speed of 2 meters per second over a period of 1.5 seconds, and then travels at the speed of for 4.5 seconds before decelerating to rest over a period of 1 second. The elevator then remains at rest for 6 seconds before accelerating at a speed of v meters per second downwards over a period of 2 seconds. The elevator travels at this speed for a period of 5 seconds before decelerating to rest over a period of 1.5 seconds. Find the accelerated elevator during the first 1.5 seconds. So the acceleration will be the gradient, which is 2 over 1.5, which is 4 over 3 meters per second square. Given that the air starts and finishes its journey on the ground floor, find V. So if that's the case, then the area here must be equal to the area here. Distance must be the same. So area is it's a height 2 over 2 is a trapezium. 7 plus 4.5 equal V over 2. 8.5 plus 6. V equals to 2 times 11.5 over 4. Made a mistake, sorry. This is fine. Numbers is too small. So this is 13.5. So you don't get an exact value. So I'm going to put the answer as a fraction. 6 over 27 meters per second. Okay. The combined weight of the elevator and passengers on its upward journey is 1,500 kilograms. Assuming there is no resistance to motion, find the tension in this elevator cable on its upward journey when the elevator is decelerating. So the deceleration is 2 over 1. So the deceleration is 2 over negative 1, which is 2 minus 2 meters per second square. Let's take this. That's the tension of the spring. This is the weight. Combined weight is 1,500. So the weight is 15,000 newtons. Up A equals negative 2. Equals to MA. F is the resultant force, which is T minus 15,000 equal 1,500 times negative 2. T equals to 12,000. That's it. You have it. Now, always questions on acceleration is always F equals to ma. A block of mass 5 kilograms is being pulled along a rough horizontal floor by a force of magnitude x Newton, acting at 30 degrees above the horizontal. The block starts from rest and travels 2 meters in the first 5 seconds of its motion. Find the acceleration of the block. So you're given S equals to 2. E equals to 5. U equals to 0. because it starts from rest. This is the time. And you asked to find A. So using the Subhat formula, S equals UT plus half AT square. You have 2 equals 0 plus half times A times square. So solving this, you get 0.08. Believe that's the answer now. 0.16. 4/25. 0.16 meters per second squared. Given that the coefficient of friction between the block and the floor is 0.5, so there is a friction here. Find X. So again, the resultant force is MA. F MA. Resolving X horizontally, you get X. Okay, we're going to find R. R is the contact force, which will be equal to the weight. R is equals to the weight, which is 50 Newton. So X cos 30 minus mu R, which is the friction, equals to 5 A. X cos 30 equals to 10 minus mu, which is 0.4 times 50 plus X equal 30 over cos 30. 3 over 2. Or 23 Newton. Okay. The block is now placed on the part of the floor where the coefficient of friction between the block and the floor has a different value. The value of X is changed to 25 and the block is now in limiting equilibrium. And the value of the coefficient of friction between the block and this part of the floor. Okay, that means your friction is equals to X. Cos X cos 30. So your mu R is still the same, which is 50. X is 25. Cos 30 is 3 over. It's mu. Equals to 3 over. Okay, that's the answer. The particle move in a straight line. It starts from rest from fixed point O on the line. Its velocity at time t seconds after leaving O is v meters per second, where v is equals t square minus 8t power 3 over 2 plus 10t. This is a question of kinematics, differentiation, integration. Find the displacement of the particle from O when t equals to 1. So S equals to integrate V dt starts from O to 1. So integrating t, you get t cubed over 3 minus 8t 5 over 2 over 5 over 2 10t squared over 2 0 1 over 3 minus 2 16 5. So you have this is 15 times 575 plus 580 over 5 minus 48 over 5. You get 32 over 5, which is 6.4 meters. So in this question, you have to be careful. This is a 6-mark question. So stationary, okay. Okay, there might be a check and balance later. Show that the minimum velocity of the particle is minus 125 meters per second. So this is stationary, so you have to differentiate dv over dt. And it is minimum is equals to 0. So you have 2t minus 3 over 2 times 8 is 12, t half plus equals 0. So this one you have t minus 6t half 5 equals 0. So you have t half minus 1 5 equals 0. T half equals to 1. T half equals to 1. So this is the check and balance. T equals to 25. So you got to determine when is it. So I believe this would be the minimum. So just to confirm, you do a second differential. Equals to 2 minus 60 minus half. Okay, so when t equals to 25, this will be equals to 2 minus 6 over 5, which is 4, 5. It's a minimum. So this is the value when the velocity is minimum. So v will be t square minus 8, 25, about 3 over 2, 10 times 5. 625 minus 5 cube, 8 times 125, 1000. This is 25. Okay. That's it. Minus 125 meters per second. Okay, last question. Now, this paper is quite friendly because most of the question they are diagrams. Two particles P and Q of masses 0.5 and m kilograms are attached to the ends of a light inextensible string. The string passes over a fixed smooth pulley, which is attached to the top of two inclined planes. The particles are initially at rest with P on a smooth plane, inclined at 30 degrees to the horizontal, Q on a plane inclined at 45 degrees to the horizontal. The string is taut and the particles can move on lines of greater slope of the two planes. A force of magnitude 0.8 Newton is applied to P, acting down the plane, causing P to move down the plane. It is given that M is 0.3 and that the plane on which Q rests is smooth. Find the tension in the string. So this is T tension. Q rest is smooth. Okay. So this will be then if it's initially at rest, then it is in equilibrium. So T should be T should be 10 M sine 45. Okay. So M is 0.3, so 10 times 3 is 45. So 3 root 2 over 2 Newton. It's given instead that plane on which Q rests is rough and that after each particle has moved distant, their speed is 0.6 meters per second. The work done against friction in this part of the motion is 0.5 joule. Use energy meter to find the value of M. Okay. So the increased in kinetic energy for both particles is so the total mass. So it is half times 0.5. This is the question. So you've got to explain a bit about this question. So this question is not a simple question. Let's draw the diagram first. So here this is Q. Let's move up 1 meter. E. Move down also 1 meter. And with a force of 0.8 newtons. Putting it. Okay. So we can disregard the tension because it is in opposite direction. Okay. Now, gain in kinetic energy. Half times 0. This is for P. Times 0.6 square, which is for P plus half M 0.6 square. Okay. Plus the work against friction 0.5. Q will gain potential energy. This is the height. Okay, so sine 45 is h over 1. So h is sine 45. So 10 mg sine 45 equals the lost. So work done in the line, in the direction of the force is a lost. So this is 0.8, which is the force of 0.8 times 1. Okay. Plus P will lose potential energy. So P is 0.5 times 10 times sine 30 degrees. Okay, there we have the equation. So 0.6 square is 0.36, 0.18, 0.09 plus 0.18 m to 2m equals 0.8 plus 2.5. Okay, therefore m equals to 2.5 minus 0.5 minus 0.09 8 plus 5. 5 minus 0.5 minus 109 over 0.18 plus 5 to 0.263. Okay, that's it. If you like, subscribe. And if you want the working, you can always put a comment and I will send the paper to you. For now, bye.